And then we're done. We're done with that proof. I'm going to do one more, but that was just 5 steps. I went through the math portion and then labeled what choices or movements I made. So I'm going to go ahead and start writing my given for parentheses m minus n. I've got 2 letters here, equals negative 12 when n is equal to 2. So it's giving me the value of one of the variables. So what does that mean I might have to do? So I write my given statement. I write given as my justification. That is why I am writing that statement, because it was provided for me. It was given. Now, you could attack this 2 different ways. I suggest taking into account this provided piece of information, that n equals 2. If that means you can replace n, what is that called when we can replace a term with another that it's equal to? Sometimes we can replace it with another term, but sometimes we can replace it with a number. That is called substitution. So I'm going to plug in or substitute for n a 2. So for m minus, instead of n, I'm going to write 2 equals negative 12. And that's substitution property. And then I go to solve for m. I'm trying to get m by itself. So next I will, let's see, I have that parentheses that tells me I'm going to distribute. So for m minus 8 equals negative 12. Distributive property. And from here, I need to continue to get m by itself. I'm going to move that negative 8. How do I move that negative 8? I'm going to add 8 to both sides. So 4m equals negative 12 plus 8 gives me negative 4. So that was addition. And then from there, I'm going to isolate that m. I need to get that 4 away from it. How do I get that 4 away? I'm going to divide. So m equals, if you divide by 4, negative 4 divided by 4 is going to give me negative 1. So we use division. Now this last piece, I've got m in statement number 5. I have m on the left-hand side, but in statement 6, I have m on the right-hand side. It's like they are symmetric of each other. They're the same, but they're not identical on the left and right-hand side of the equal sign. So they are symmetric. So the symmetric property. And that is your introduction to proofs.